The more that you learn, the more places you'll go. So we are back again with another webinar this week. Our speaker for today is Karthik Kondpak sir. He has experience as a developer in core.ai, is a programming analyst in Ramco, and a big data developer in CITI. He completed his Bachelor of Technology BTech in Electronic and Communication Engineering in VIJT. He has an extremely good grip over Hadoop and its internals. So let's give him a hearty welcome to begin with the session.
Hi, hi one and all. Hi, hi. It gives immense pleasure. You invited me as a guest speaker here. So let me introduce a brief introduction about me. So myself, Karthik Kondpak, currently working as a big data developer in City. It's a Fortune 500 company. So it's become it's an like when you go for development, it's a product base is a like a dream company for everyone. But when we go for big data or data kind of thing, so City like financial sectors are the very financial sectors play a prominent role in our like data kind of industry actually. So it's my dream to enter into City. So like City was a dream company for me and I achieved that. So so let's start with our guest lecture. So actually,
Sir, Karthik sir, just a minute, sir.
yeah,
Sir, could you please turn on webcam? Our faculty coordinators will also turn on their webcam. We'll take
sure,
a
sure,
snap, sir.
sure, sure, sure.
Yes, sir. And here our Sudhir sir is the faculty coordinator for Microsoft Student Chapter.
Hi, sir.
Yeah.
Hello, Karthik.
Yeah.
Thanks
Hi,
for
hi,
coming.
hi. Thank you, sir. It's immense pleasure. You are inviting me as a guest speaker.
Ganesh sir, could you,
Hi, sir.
sir?
Hi, Ganesh sir.
Karthik sir.
Hi.
Thank you for accepting our invitation. Even it is a hard time for you actually Sunday. Still
Yeah, no,
you
sir.
are
No,
accepted our
no.
institute.
Actually, sir, I'm an educator even. I'm educator
Yeah.
even. I mentor
Very
students
good.
even.
Yeah.
So as a like I have my own platform even where I teach even actually. So it's an
Okay.
immense pleasure. It's an immense pleasure you calling me as a guest speaker. It's a very honor. Like if I can say it's more than the remuneration why what I earn. So it's a
Okay.
very honor, sir. Thank you.
Thank you, sir.
Thank you.
Okay, sir. Please
Okay, sir.
continue, sir. Thank you.
Yeah, sure, sir, sure. Hi guys. Hi guys. Today's topic I actually decided the caption as data is the new oil. Why actually I choose the data as the new oil. First, let us understand the things. So actually, you know that like previously the things was like every our data used to store in one machine actually. Like in 2000s, during 2000s, what used to happen is like our data used to store on single machine actually. So what happened is like on like let's consider your PC only. Now let's consider your PC only. Your PC consists of only 1 TB of hard disk actually. Let's consider tomorrow if I got a data of 2 TB of data, what actually happens? So these things actually Google has predicted in previous in 2000s only. So what actually started like I will tell you the whole journey of data. Then you will can understand everything. So first what happened is like during 2000s actually Google has a web search. Google started its journey with web search, Google web search. So at that time what happened? So at that time Google thought that like Google already predicted that in the ongoing feature the users the utilization of users the utilization of web search Google web search will gonna increase. So what it thought is like it thought that like now we are dealing it's okay, now we have some kind of people and we are able to deal with one system only. Now we are able to meet the customer needs and customer demands, it's okay. Now let's consider tomorrow some 30 some more than 100 TB of data or more than 200 TB of data comes at one time. How we have to deal that? So that is what actually they started. They so what they did is like now they came up with a white paper actually. White paper is nothing but a conceptual. It's a like you can say it's a theoretical concept. So what they said is like they said that they released a white paper in 2003 and Google said that if we get some if we get the data which is not at all capable of storing in our system, let's consider your PC only. I think you have every one of you has a PC. In your PC you have 1 TB of hard disk, right? If the data comes more than 1 TB of 1 TB, then you can't able to store that. The same thing happened with Google also. So Google predicted that in future definitely this is gonna happen. So what they did? So in 2003 they implemented a white paper. In that they said that there should be a possibility that we should divide our work. Let's consider we got some 10 TB of data today. So we'll divide that work into multiple systems. We'll divide that data into multiple systems. Let's consider 50 GB to 50 GB to one system, other 50 GB to another system. Look, in that manner we'll divide the data and will divide the data into multiple systems. So it actually given the theoretical concept, but it doesn't implement it. So at that so after what it did, now it said that like in 2003 it only said that how to store the data on multiple systems. But you know that processing now it has given that how to process the data, now how to store the data on multiple systems. Theoretically it has given. Now it also said that how to process the data. In 2004 what it once again in 2004 it said that how to process the data. It again in 2004 it given a white paper which is nothing but a proof of concept, like theoretical concept. Theoretical it said that we can like you know that you work on C language, Java language, all those, right? Those C language, Java language, Python language are the languages which will be working only on single machines. Let's consider your PC. If your data is present in your system only, if your data is present in your system only, then on that data only it can work. It will not. Let's consider if your data is stored on two computers, then you whatever the programming language, whatever the logic you will write, that will not work actually. That will not work for both systems. Whatever the logic you will write, that logic will work only on your system only. So here process is nothing. Don't consider the term which I am using, processing. Don't think it like a big one. Just simple. Process is nothing but whatever the, let's consider you are writing a prime number. Let's consider you are writing a prime number logic. That prime number logic, what it is giving for the input you are given, it is processing and it is giving you the result. This is what actually the process will say, process or processing. So the logic which you are written, right, that is all actually we called as process or processing. So actually what happens now already, and I said that like C language and Java language and Python language, these are the process which these are the logics actually which will work only on your system. Only on your system. It will not work on multiple system. Let's consider you have now let's consider you have some 10 TB of data. Now we have divided the data on multiple systems. On 1 TB of data is present on one system. Another TB of data is present on other system. Such we have, let's consider we have such 10 systems. Now you have stored the data. Now you have to process the data. Let's consider you want out of that 10 TB of data, you want some data. Let's consider that you want some sales, like consider that data is related to the some students related data only, your attendance related data. So I want so that is 10 TB data. Now I want to have I want a output that how many students are present continue, like how many how many students are present for one, like some percentage. Let's consider 70%. How many students present for 70%? How many students have 70% of attendance? Let's consider. So I have to process that. See, literally obviously we have to write some logic. That logic will say as process. So now if you are storing on one computer, your C language, Java language, Python language will work. But if your data is present on multiple systems, then it will not work. Then what actually Google did? Google said that it 2004 it released a white paper. It said that there is a process where we can even process even if the data is stored on multiple systems, we can process that. So on that scenario, it given a definition called, there is a process called map reduce. there is a power process called MapReduce, and it said that MapReduce can process if the data is present on multiple systems. So now Google has given a definition how to store the data on multiple systems. Even also said that how to how to process the data if it is present on multiple systems. Now the scenario comes that now it has given only a definition. It has only given a theoretical definition, but it has to be implemented because here ongoing the demands are now the data is increasing day by day, and demands also growing day by day. So we have to implement it. So what they did is like in Yahoo in 2006, Yahoo in 2006, Yahoo in 2000 published regarding like a storage, and after that whatever it launched in 2004, those two white papers taken by Yahoo in 2006. And what they did in 2006, they implemented the process, they implemented the things, this distributed computing, distributed storage means nothing. When your data is stored on multiple systems, that we call as distributed storage, because it is distributed, data is distributed between multiple systems, so we call it as distributed storage. And when your data is present on multiple systems and you are processing that, we'll call it as distributed computing. So in 2006, Yahoo took that papers and it implemented, and after implementation it has given two names, it has given the names. Previously distributed storage, whatever the Google has launched, for that Google given a name called Google distributed file system, Google distributed file system. For that, after Yahoo, when in 2006, when it implemented the procedure, like implemented the whole flow, how actually like how actually the things to be done, like when when it implemented, it has changed its name and it's kept name as Hadoop distributed file system, HDFS. After that now it's come to computing also, like how to compute it implemented, it implemented MapReduce as well. So MapReduce, so when it comes to MapReduce, in MapReduce also, like it implemented and it kept MapReduce as the same name, it didn't change the name of MapReduce. So we got HDFS and MapReduce. So this is actually MapReduce, MapReduce is for computation and HDFS is for the storage. So this is the Hadoop 1.0, Hadoop 1.0. This is actually the picture, like what actually happened during the data. So let's go now we'll go with what actually the big data scenario is, what actually the big data is. So actually the thing is, if I can say simple terms, so actually many people say that big data means, big data means the data which can't be stored in our computer. Let's consider you have your own computer that might have 1 TB of data. Let's consider if you are getting the data which is more than 1 TB, then obviously this is our traditional system, your PC, you can't store on that. So many people given many definitions, like say someone said that if the data is not at all not able to store on my computer, then it is called big data. Someone said that like
Excuse me, sir.
yeah.
Yes, sir. I think you can. I mean, we can't see your screen, sir.
So actually I'm just explaining. Hello.
Yeah, okay, sir.
Okay,
Continue, sir.
Continue, sir.
Sure. So will I have doubt? If you have any doubts, we'll have at the end this session, actually at the end of the session. That will be fine. Okay.
Okay, sir.
Okay, fine. So let it be. Hello. You are able to see my screen now?
No, sir.
Still, just give me 1 minute. Now you are able to see my screen, right?
Yes,
Hello.
sir. Yes, sir.
Yeah. So actually, see, we'll understand now what actually the big data is. So there are multiple definitions given by multiple people. So, but there should be some standard definition which we can follow, right? So what actually people did is like, see, some people said that when data is large or when data is huge, we call it as big data. Some says that when the whatever the data we have, if it is not able to store on our laptop, then they said that it is termed as big data. But there should be some formal definition, right, which actually everyone should follow. So at that into the like that IBM is one which has been a part of very revolutionized things. So as a part of that, so when like IBM given a formal definition for big data actually. So what it did, what it said actually is like, see, if our data, whatever the data, if it is having three characteristics, if it follows three characteristics, or if it fulfills three characteristics, then we can call that data as big data. So what are the three characteristics actually? Let us know. So there are three characteristics. The first characteristics is like volume, then variety, and their velocity. Volume is nothing but when let's consider volume of data should be large. It means like your data should be very large. It should be in some terabytes or petabytes. Simply, if I can say, see, that if your data is in terabytes or petabytes, see, petabytes is nothing but, see, 1 GB is 1024 MB. 1024 MB. If you have 1024 GB, then it will be petabytes. So in that manner, see, one petabyte also we can't store actually in our machine. So if you have 1000 petabytes, you can't even store that. So actually when your data, that data can't be stored on your system. So such a volume of data, is called big data actually. And it only this one character is doesn't refer that it is big data. So it also said that even variety of data, let's consider you may have variety of data. Your data might be structured data is nothing but you may know SQL, MySQL, like table kind of things, right? So structured data like variety of data, structured kind of data will be there, unstructured kind of data will be there, semi-structured kind of data will be there. Semi-structured is nothing but JSON format, CSV format. Unstructured format will be the audio, video, image, log files. So what I specifically mean to say is like your data, your big data will consist of structured, semi-structured, and unstructured, three things. So after that, when it comes to velocity, velocity is nothing but the speed at which your data is coming. The speed at which your data is coming actually termed to be big data actually. Let's consider like the speed, like you are getting the data. Let's consider you are getting the data and you are getting the data with some speed, like the speed at which the data is processing into the system, the speed at which the data is ingesting and retrieving. So don't think that these terminology is a big one, but ingestion is nothing but simple. If I can say, you have some data in your Oracle. Let's consider your data is present on your some database. So you are moving the data from one layer to other layer. Let's consider the other layer is nothing but movement of your data. Your movement of your data from one point to other point, one storage system. Let's consider, I already said that for distributed storage, we have HDFS, Hadoop Distributed File System. Now, when you are moving your data from database to Hadoop Distributed File System, that actually terms to be ingestion. So we call that as ingestion. So we in simple words, so speed at which data is coming is termed to be velocity. So what IBM actually told is like, so there should be some proper definition. So according to that, it has said that if the data fulfills three characteristics like volume, variety, and velocity, then we call that data as big data. So this is what actually whole the scenario of big data terms to be. So this is what actually the big data is. So apart from that, actually in today's life, what happen is like day by day the data is growing. So whatever the like you take whatever the data it might be. Let's consider you are using Facebook. Many people might use Facebook. Many people might be using Instagram. All those stuff. So you can even literally understand that many of the people might be using Snapchat even. So you can literally understand. I'm using Snapchat. You are using Snapchat. Multiple people are using the Snapchat. So you are when you are snapping, when you are taking that snapshot and when you are sharing it, do you know the how much data will be generating actually? So behind that, so multiple, so much amount of data is generating on a day-to-day basis, minute-to-minute basis, and second-to-second basis. So those things are actually has to be handled. So those things has to be handled. So if you like you want to handle that data, can you do you think that it can be dealt on one system? No, it can't be dealt on one system, because let's consider, I will give an example. So let's consider you many people might know, like many people use ATM. So ATM, you know that if, sometimes you feel that ATM is not working, or ATM is some server problem, all those issues. Do you know that what how on what basis ATM will work? So ATM will work. ATM system, or what are the system, what are the software that is present inside the ATM will be present on only one server only. One server, in the sense it will work. It will be monolithic system. Monolithic is nothing but actually the data will be present on one system only. So I will understand, I will tell you what actually this distributed computing and what actually the monolithic and distributed system. So actually what happened is, like, now we got to know what actually big data is, the formal definition given by the IBM. And one more thing also, we got to know what actually, like, how actually big data come into the system, what, who has implemented. We said that Google has given the white papers, and Yahoo has implemented it, and it has given the names, even HDFS as Hadoop distributed file system, and these things. So this is done. We have come. Now we need actually a system. Actually, we actually at the moment when they thought like what, where to go with, like, to deal with this big data, they thought that currently we are having two things: monolithic systems and distributed system. Was the option for them for which to go, which not to go. At that moment, they first analyzed where to go with. Actually, let's go with analytical monolithic systems or big data system. So before that, what they thought is, like, we have to analyze in a brief manner, and then we have to understand. So first, I will make you I will make you understand what actually the distributed and monolithic systems are. So monolithic systems are nothing but a big server, a big system. Let's consider your system as well. Your system only. Your system has some 8 GB RAM and some 1 TB hard disk. This is what actually the monolithic system means. We call this as monolithic system. So what is the problem with monolithic system is nothing but, see, now we have 1 TB of data. You are able to store the data, and you are able to manage everything. That's fine. Let's consider tomorrow you got 2 TB of data. Do you think that you can store that 2 TB of data on your system? No. So what you will do? So obviously nowadays many people know, but at that time what people used to do, they used to increase their hard disk. They used to increase their hard disk and whatever the resources present in their system. Now 2 TB, now today 2 TB data I got, so I increased my resources. Tomorrow I will get some more than more than more than 2 TB of data. Let's consider I got 10 TB of data. I will increase. I am still at that point. I'm increasing. I'm increasing still to meet the demands. Do you think that if I get 100 TB, if I get 100 TB of data, if I still go on increasing on the same system, if I'm increasing the resources, do you think that you will get the performance? Performance is nothing but, see, simple. Performance is nothing but the response is nothing but, if you are, let's consider your phone only. When you are clicking on one app, or when you are clicking on one photo, if it doesn't give you a response very soon, do you think that you will use that phone? No. Everyone want the things to be happen in a very quick manner. That is what actually the response is. So what actually the things. So the thing is, like, now they have got a drawback that it's hard to deal with monolithic systems. It's hard with, because the thing is, like, tomorrow we might get 100 TB of data if we increase our resources on the same system. So at some time, after some time, or after some threshold limit, actually what happens is, like, today you got 1 TB, you are storing you have 1 TB of data you are storing. Tomorrow if you got 2 TB, you are increasing data. Tomorrow, day after tomorrow, you are getting some 100 TB you are increasing the data, but actually the thing is like you after some threshold size, when you increase your resources, your performance will not be increased in case of monolithic systems. Your performance will not at all increase. This is a first drawback with monolithic systems. So performance is not increasing, so that's fine. I will give an example even with this monolithic system. Let's consider you think that you have a truck, you have a truck, and in that truck you have so much of load. Let's consider you have some things, some big things. Now the thing is like you have to, now there is only one guy who has to keep that things. You have to move that things from truck to the home. Let's consider you have only one guy. Do you think that that one guy, that let's consider approximately that time will the time to move that things from that truck to the home will take some around 10 hours. Let's consider 10 hours. So if I make that guy to eat full, if I make that guy to eat lot, do you think that he will make that 10 hours of time will get reduced? Or if you give lot of money, do you think that the time which he is taking for 10 hours, let's consider approximately we have said that it will take, obviously it will take 10 hours. If you give a lot of money and if you make him eat lot, do you think that he will reduce the time, he will complete those things in 5 hours? It will not happen. Similar thing here also. Similarly here also I am saying the same thing. What I am saying, on the same system we are increasing the resources. On the monolithic system, that doesn't give any performance. That is the reason you never see our systems. You never see our systems with 100 TB DAS hard disk or 1 TB RAM. Have you ever seen that there will be a system with 1 TB RAM and some 100 TB hard disk? No. Obviously, and normal max to max we have seen 128 MB, 128 GB RAM. That's it. So why? What's the reason? See, what's the reason is like after certain limit or after some certain threshold limit. Actually, even if you increase, even you increase your resources on your system, you will not get the performance. Performance is nothing but the response. So whenever you are increasing the resources, actually the performance should be doubled. The response should be doubled. Response should be within very speed manner. So that is what actually the drawback. This is the first drawback. This second drawback is like, let's consider you are storing whole things in your own system only. I have given you the example of ATM. You sometimes feel that ATM is not working due to server issues, all those. Why actually it happens is like basically your data is present on only one system. That is the reason that you one kind of server only. That is the reason when it fails, there is no alternative that it will get connected to other and you will get that. Actually, that is basic the reason. So they are not going with distributed kind of things. So now what actually distributed computing is? So distributed computing is nothing but, let's go with distributed computing. Now they understood the drawback of monolithic. So now they started going, they started as I'm analyzing the things on distributed computing. So in distributed computing, what happens is like, see, let's consider you have some 10 TB of data. So what they did is like in distributed computing. So distributed system, sorry, they have divided your data to multiple systems. If I can say in simple terms, multiple systems will come together to solve one problem. That problem, to solve that problem, that is what actually we call as distributed systems. So what multiple systems? There might be, let's consider each system we call technically each system in this distributed systems called as node. Each system is termed to be a node. So the thing is like, let's consider you having 10 systems. So we call that as 10 nodes. 10 nodes. So 10 nodes will be storing the data. Let's consider you having 10 TB of data. Then 10 systems, each system will be carrying one TB of data. 1 TB will be carrying with one system and other TB will be carrying with one system. So going on, 10 systems will carry 10 TB of data. Now, do you think that one system dealing 10 dB of data and 10 system dealing 10 dB of data, there's a lot of difference. Let's consider if one system dealing 10 TB of data, it's not possible. First of all, let's consider for a while, let's consider that let's consider one system is able to deal with 10 TB of data. Now one system dealing with 10 TB of data and 10 system dealing with 10 TB of data, there is a lot of difference. For one system dealing with 1 TB of data, if it takes 10 hours, 10 systems dealing with 10 system dealing with the 10 TB of data will get the result in 1 hour, or else we can say in some minutes even. So that is what the beauty, or the what we can say, that is what actually the whole concept or the whole funda behind distributed computing. So whatever big data, see, big data is not at all a technology. First of all, you have to understand, big data is a problem. To solve that problem, this distributed computing, distributed storage, this actually came into the picture. This is what actually you have to understand. So we got to know that distributed computing. So in distributed computing also, I will give you a simple example. I already said that there is a truck, and in that truck there is a lot of things, and that things you have to now you have to move those things to the home. So previously in monolithic system, I said that there is only one guy, and we are feeding him. If you feed him a lot also, if you give money lot also, the time will not change. But when it comes to now in distributed computing, what we are doing, same truck, we are saving things. We, instead of making one guy feed a lot and giving him lot of money, what we are doing, we are distributing the things. What we have done now, we have increased one person to 10 persons. Same thing, same truck, same things, same truck, but now we increased the number of people. So now 10 people will move that things. Don't you think that now the time will obviously get reduced, right? So this is what actually the distributed computing is. Distributed systems actually works here. Distributed computing also, distributed storage also, everything will work in this pattern only. So this is what actually we call as distributed systems. So after that, when they compared monolithic systems and distributed systems, at that moment they understood that distributed systems are the finest ones, and they will definitely solve our problems. So at that moment, actually they thought is like there should be something which there should be something, or that something is nothing but like there should be something which actually should solve our big data problems, and that should be some distributed, that should be some that whatever the technology or whatever which comes to solve this problem should consist of some properties. Actually it thought is like, definitely whichever solve this big data problem must consist of a distributed storage, distributed computing, and something which manages this distributed computing and distributed sources. Let's consider, I already said that there is a storage. Let's consider, I will give an example. Simple. You consider this truck. In that truck, you are able to store everything, right? So that, consider that as SDFS, that is your storage. Now you got storage. Now you want computing. You got 10 people. Now we have chosen our distributed systems. So we are having 10 people now. 10 people, and we have a storage called truck. Our whole things are stored there in truck, and we are having people even 10 people and storage. So now there should be one guy, there should be one thing which should manage all those things. Let's consider how many people you want. Let's consider today you have 10 people, but tomorrow you might want 20 people. Today you have one truck, tomorrow you might want two trucks. There should be one manager, right? There should be one manager where where he can where you, if you request him like saying him that we want actually tomorrow our load is lot, we have a lot of storage, so I want two trucks, I want 20 members. So there should be someone where to whom you should say that we want these things. So there should be someone. So in that perspective, actually in that perspective, there was a manager even. So what actually happened, so there was a manager even. So so these three things, so they said that whatever the technology or whatever the thing which solves this big data problem should consist of these three things. There should have one storage, there should have some computing, and there should be some manager. In that context, what actually they found is like the Hadoop. Hadoop is one of the thing which has all these properties. Hadoop. So what actually Hadoop is like? Hadoop is nothing but a framework. In Hadoop, actually, you will get distributed system, distributed computing, and a resource manager. So when Yahoo implemented, when Yahoo, I said that Yahoo implemented these things. So when Yahoo implemented these things, so at that point, that was the Hadoop 1.0 version. So at that time, actually, what happened is like it Hadoop 1.0 version. So at Hadoop 1.0 version, this we have only two things: HDFS for storage, HDFS for storage, and the computer MapReduce for computing. These two things are only there. And Hadoop MapReduce used to do computation work, as well as it used to be manage. It used to be the manager work also. It used to be do manager work also. Those two things it used to be do. So this is what actually it used to be do. So this is what actually done. So on later what happened is like, see, I have given an example of truck where actually the things used to be stored, and the people who are moving your data from one side to other side, those are like computation engineer. So in Hadoop version, these people, what are the people? You have some 10 people. That 10 people only used to be manager as well. They used to manage. They used to be one managers as well. So later the thing is like they are actually doing that work. They are transferring your things from one place to other place now. So that managing kind of things actually later going on further actually become a lot of problem, because when they either should concentrate on moving the data or managing data. So these all things has to be done. So previously in Hadoop version, MapReduce used to be do MapReduce used to do the same thing. Actually, that was the biggest problem in MapReduce, Hadoop 1.0 version. So later what they did is like in Hadoop 2.0 version, they have divided this like Hadoop version into they have divided this MapReduce into two things. One should be the one MapReduce should be the which should only concentrate on this processing kind of things. And they have divided the third thing which they have divided, they named it as resource manager. You simple terms This is simple term, you can understand it as a manager which can manage whole the work. What are the resources you want and what are the computation power you want, these all things will be managed by the TIAN. We can say it as resource manager. But in industry, actually, most probably in industry, the resource manager which will be using is like YAN. YAN is the resource manager actually which we'll use. So now we got to know that Hadoop is a framework. It consists of distributed storage, HDFS, distributed computing, MapReduce, and a YAN manager who manages these things actually. So now we got that Hadoop is a framework. This will solve our big data problem. So we got to know. So actually, what happened is like even MapReduce, the MapReduce was implemented by Yahoo. That's fine. So what happened is like even MapReduce has some glitches. What are the disadvantages of MapReduce is like, what MapReduce used to do is like, MapReduce has so much limitations. Let's consider when your data increases. Let's consider MapReduce. Like let's consider I said that our here in this environment in big data environment, actually your data is stored in multiple systems, distributed, because big data works on distributed systems only. Distributed, everything will be happening on distributed things only. So I already said that our data is stored on distributed systems. So what that like on multiple systems our data is stored. So when our data is stored on multiple systems, 1 minute, 1 minute guys. Hello. When our data is stored on multiple systems, so what happened is like we said that let's consider we are having some 10 TB of data. It is storing in 10 machines. Tomorrow you might be getting 100 TB. Let's say tomorrow after that you might be getting some 400 TB also. So what actually like what there was a disadvantage with MapReduce is like it used to like after 4,000 nodes. 4,000 nodes means after 4,000 machines. Let's consider if you are now you are having 4,000 machines. When you are able to increase your machine size beyond 4,000 machines, at that time it won't use to allow. It means like it's not like that, it not used to allow, but the thing is like the performance issue used to come. You are not able to increase that for beyond 4,000 nodes actually. So that was the biggest problem with biggest problem with MapReduce. So now whenever the problem arises with something, definitely another thing will be an option, obviously. So at that moment, actually Spark came into the system. Spark. I think you have listened about this Spark. That is also one of the computation engine. And what actually Spark? What are the disadvantages whichever you have found in MapReduce? That all are reduced. That all are minimized by the evolution of actually the Spark. So what actually Spark? Spark is nothing but it's kind of computation engine. It is not an independent kind of thing. It actually, see, whatever the computation engine it might be, whether it may be MapReduce, whether it may be MapReduce or Spark. So these are the computation engines. They don't have their they are just the computation engines. They are just the computation engines. They are not the programming languages. So they are not independent. They will depend on one of the language. Let's consider MapReduce. Previously used to MapReduce, you can write in Java. Huh? So when it comes to Spark is dependent. Spark can be can be written with the help of Java, with the help of Python, with the help of Scala as well. These are the three dependent languages on which actually Spark depends on, and using this, it will write actually the processing logic. This is all the scenario about like big data, all those kind of stuff actually. So hope people you understood this, and let me know if you have any doubt one by one. Like I will try to clarify your doubts regarding big data even. Hello. Hello. Hello.
Yeah, Karthik sir, you're audible.
Yeah. So if any one of the you want to learn big data in bigger perspective, or if you want how to get into big data, all the stuff, or else whatever the lecture I have given till now, if you find any glitches, or if you don't understand this particular thing, what distributed computing is, what actually the big data is, what actually like in particular scenario, what that particular mean, so in that pattern, just let me know. Anyone, even faculty members, even like sir, Ganesh sir.
Yeah, guys, if you have any queries, the stage is yours. You can ask your queries.
Yeah, you can ask anything, like don't be hesitated. You can ask whatever you want, like if you have any doubt regarding big data, how to get into big data, like whatever it might be.
Yes, sir. I think the students didn't have any queries, or else
Yep.
definitely we'll share your LinkedIn profile, sir. That would be useful if they have any
Yeah.
queries.
Just
They
just
can
just
directly.
just let me know. Just give me 2 minutes. I will try to enhance those things even. Like it will be better actually. Let me share. Like I think you are able to see my screen, right? So this is what actually the platform like which I built. This is called 𝐶𝐞𝐿 Big Data, which only means that what like a 𝐶𝐞𝐿 is nothing but learn big data, and data is the new oil actually. So this is what actually the caption, this is what actually the platform is. So you can go to like Play Store even, and you can find that like there will be a platform where actually you can directly download that go like this 𝐂𝐤𝐿 Big Data app, and even you can chat with me. Let's consider now in this webinar, you might not be like you might be hesitating, like you many of the people might be hesitating that like to answer up in this in this much people. So you can directly personally or like at that moment you can directly chat with me. You just have to download the app, and you just have to register. Like there will be few details, like what personal details, like your name, your email, your phone number. That's it. And after that, just we'll get a OTP number, and for that OTP after just once you logged in, you can have a chat with me. There will be a chat option, and you can have that. And if you want, if any one of you, like whoever it might be, if you want to learn big data or else like to know more about big data, so you can book a slot even with me. Like you can find TopMate on TopMate. You on TopMate, you can just go there and you can book this slot with me, and you can have one-to-one session with me even. So apart from that, you can even I will share you my LinkedIn profile as well. I will show you my LinkedIn profile. That will be the fine. Like hope that will be lot helpful for you. This is my profile actually. My name is Karthik Kondpak. So you can go here, you can go over here and just try to connect. Like if you want, you can connect with me. So this is what actually. So guys, can you tell me how was the session? Like because like I never like specifically I never go with PPTs. So that is what actually my lecture is. So it's not like it's not the first session for me, or this is not the first webinar for me. So actually I never think that PPTs will make the people understand. So actually whenever I speak, whenever I make understand, I will try to give simple examples, and I will try to make the people understand the things. Because like I don't think that PPTs, reading the things on from PPTs will make the people understand. It's kind of boring kind of teaching which actually I used to face during my college days even. So I never prefer PPTs. I always try to like I will always try to explain on notepad, or else I will try to have everything on notepad. I will try to explain the things. I will never prefer those PPTs. It's up to everyone's individual, but according to me and according to my experience, I can say that like many people don't like PPTs, even like PPT kind of things. Reading the things from PPT and explaining the things is not that effective actually. So like guys, can anyone like from even like from Ganesh sir or whatever the faculty members who are present here, and all the the managing kind of things like Tinku and whatever the people who are here, can you briefly tell about how was the session? Like can you give the brief feedback? That will be very cool for.
With everybody.
Hi. Okay.
Any students can give a feedback on it.
Yeah, that will be cool. Like
Yeah.
do you understood loud what actually I spoke about big data? Like any student, it will be cool, because we see your feedback will matters a lot. Like because like if I want to conduct any with the permission of your faculty people, let's consider if I want to conduct any workshop to your college, even like that will be like it will be very helpful for me even, because I do conduct workshops in even in the colleges, like for 2-day workshop, 3-day workshop, we will conduct actually technical workshop. So that will be very good for me. Yeah. So your feedback matters.
Bajbabu, yeah, you can talk about few words about.
Yeah.
Yeah, sir. Yes. Yeah, yes, sir. Karthik sir, it's really wonderful and inspiring and encouraging words from your side.
Okay.
Yeah, it's a wonderful session, sir.
Yeah. Thank you. And Ganesh sir, how you felt regarding the session?
It's really required, sir. That collecting useful data is very essential nowadays.
Yeah, sir.
Definitely, this session really helps us, our students, how to manage big volumes of data, how
Yeah, sir.
they can extract.
Yeah.
It's really good. Really good.
Actually, I didn't went into the much architectural kind of things because, sir, people might not understand. They might be confused even because these are like they can't understand the technical terms. So I actually try to take the example of truck people such that they can understand the things in a better manner.
To map with the real world scenarios, then they can easily understand.
Yeah, sir. Yeah. So actually, sir, one more thing. Actually, I want to specifically mention to the all the dignitaries as well as the people who are like was present for webinar. So I want to tell you like specifically like previously there was a before pandemic and after pandemic the recruitment has changed a lot. So previously like recruitment has to happen offline and used to get lot of opportunities in offline. So now after pandemic everything was much like recruitment was happening on Naukari as well as LinkedIn. So LinkedIn is playing lot of role. So be prepared, like make your profile so good in like make your like optimize your LinkedIn profiles. Try to be more active on LinkedIn. Whatever the knowledge you have, just try to share your knowledge and keep your voice up in your LinkedIn. Keep your voice up in LinkedIn, and it will fetch you lot of options. See, one thing I will tell you one thing. See, once you passed out after once you passed out in from your college, actually what happens is like now your college might be providing some opportunities. That's fine. So if you after college, let's consider even in the limit of the whatever the limit college has provided the placement, if in that limit, if in that time frame, if you are not able to crack the company, definitely you have to look after the college. So after like when you once you go after the college, once you go, so what happens is like at that moment you will not find the opportunities. At that moment you have to understand how actually the LinkedIn works, or how actually the Naukari works. So try to make your profile so optimized such that you can create lots of opportunities through LinkedIn. So LinkedIn, so try to understand actually. See, always I want to tell one thing. See, every platform, whatever the platform might be, whether it is LinkedIn, whether it is Naukari, it will works on some certain techniques and certain tips and certain tricks, because certain algorithms will definitely work beyond that platform, definitely. So you have to understand, you have to analyze the things, what actually is working, what is happening in the LinkedIn. It is not just creating the LinkedIn account, connecting whatever the people you want, connecting whatever the whatever the people, like whatever the friends you have, like it is not. You have to connect with only some good profiles as well, and you have to keep consistently, you have to share the knowledge on LinkedIn. And when you are connecting, like let's consider you are, see, in Naukari also many people just what they do is like they just post their resume and they just start applying from 10 some 100 companies, 200 companies. It is not. When you apply, even you upload your resume and apply for 10 100 200 companies, you won't get the call back from that companies actually. So you have to understand the scenario, how actually the platform works. Then in that pattern you can understand actually what the LinkedIn is, how to get the opportunities. LinkedIn is the best platform to create your own opportunities, not only to create own opportunities as well as to provide opportunities for other. LinkedIn is the best platform. So try to keep your professional profile over LinkedIn, and try to be very consistent over LinkedIn by posting the content, by interacting with the people, by engaging with the people. That will definitely fetch you the opportunities. You even can't deter, you even didn't imagine or don't imagine that how much big kind of hours you will get from LinkedIn. This is my personal experience. I can tell you that even I got many opportunities from Amazon, Google. Literally I am saying, but those opportunities I got after joining some company. So literally daily, on a daily basis, I got lot of opportunities. So keep your profile so optimized so that you will create lot of opportunities, as well as you can provide opportunities to other your friends and other people even. So this is what actually. So I want to end the session here, and that will be cool. And it's like, I can say in one word, I can say this is the, like this is one of the immense like I feel very honor. I feel very honored that you have invited me for the guest lecture, and many people even joined, and they were patient for 1 hour. and if I made like if I spelled something wrong, then it's like sorry even for that. And so the thing is like, it's very immense and honor for me. You all invited me here, and thank you for being patient for 1 hour. So thank you.
Yep. Thank you, sir.
Thank you, sir. Actually,
Yeah.
even my advisor, club advisor, Baj
Yeah.
Babu also used to find the invited speakers from LinkedIn. As you said,
Okay.
it's having a LinkedIn profile and updating our skills in the LinkedIn. Definitely, it creates a lot of job opportunities.
Yeah, sir.
Definitely, we
Even
request all the students to go with those who haven't have a LinkedIn profiles. Definitely, we request
and
them.
yeah,
Yeah.
yeah. And one more thing, sir. Like if the people don't understand how the LinkedIn is, how
Yeah.
LinkedIn doesn't work, we'll even
Yes.
conduct one more kind of like a 1 hour webinar on that
Yes.
LinkedIn optimization as well, where I
Yeah,
can
sure, sir.
directly
It is
where
very much required.
yeah,
Definitely, out of box they can think so that
yeah,
within the
yeah.
college they usually we think the
Let's consider,
opportunities,
sir.
but if you want to
Yeah,
see that out of box, definitely LinkedIn is one of the best platforms, sir.
best
Thank you.
platform. And one more thing, sir. I don't
Uh,
know. Like these are the people who joined here are like third year people, right?
yes, yes.
So
Yeah,
the, so,
yeah.
so I
Most
what
of
I
them are third year, second year is also there, sir.
yeah, yeah. So what I want to tell you, like if you are at third year or if you are fourth year, just if you consistently post your content over for next 1 year or next 6 or 7 months, I'm assuring you that after 6 or 7 months, you will get lot of followers. Like you can even find that you can some people might reach 10k followers, 7k followers, 8k followers. Once you reach some 10 5 when once you reach your follower, once your reach is more, let's consider if you are having 5k followers or 6k or 7k, I'm ensuring you that you will get lot of opportunities. You don't even need to look after your college placements. Even you will get such opportunity, you even can't determine, you can't even imagine such big opportunities you will get. Instead you approaching to the companies, instead you approaching to the companies and applying to the companies, companies will approach to you. This is what happened in my case. This is what the power of LinkedIn. Just the thing is like, LinkedIn, the you should understand actually how the LinkedIn works. First of all, at that moment you will understand how you will grow lot. And all the best to you, all the best for everyone for your future. And definitely will rock, and we'll meet once again in LinkedIn session. If you were like depending upon your like availability and your faculty people's invite, will have a LinkedIn session even.
Thank you, sir. Thank you so
Thank you.
much. And I am very much thankful to my advisor and the president. Advisor is Baj Babu and president is Mohan Krishna. They rigorously works. And
Yeah,
our supporting team like Surya Teja and others, they did extraordinary job because even it Sunday, Monday is the college holidays, but still many people are attending because of these particular topics has a
yeah.
lot of weightage. So thank you sir, very much
and
for
and
the
and
efforts.
and
And
one more and one more thing, sir. This and
uh,
one more, the whole people who are present here, I want to say you one thing. See, many people, see in colleges also many people say that learn Java you will get job, learn Python you will get job, or something. But I'm assuring you that this 21st century is the data century. You will get lot of still till 2025 or 2030, data gonna rule the world, and data gonna rule world, definitely data gonna rule world. And you will find lot of opportunities in data field as well. Don't only look for development kind of like Java developer, Python developer or something. You even try to look after big data developer, data analyst, database developer, ETL developer. These all are also the kind of data kind of things. AI, machine learning. These are like data kind of fields. Data scientists. These are like data fields. So data gonna rule world. This 21st century is all for the data century. So what I mean to say is like, just try to look after these things also. These are very important, and hope you can understand the things here. Like once you grow, you can understand the things. and very much thankful to I'm very much thankful to Bab, like Tinku, as well as like Mohan and the supporting people over this VIT University. And thank you. It's like very like it's been very like honor event. So thank you one and all.
Yeah, thanks, Anna. Thanks for accepting my
Thank you all.
invitation.
Please, everyone, turn on one your videos. Will
Videos
take one
one, yeah,
snapshot. Please,
yeah,
it's good
yeah.
actually. Babu and our team, you can turn on the videos if you are comfortable, John. Thank you.
One second, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.
Yeah, over to Varsha. You can wind up with session.
Every day holds the possibility of a miracle. So keep hoping for the best and keep shining. On behalf of the entire NGC club and WIT, I would like to thank our honorable speaker. Thank you, sir, for inspiring and encouraging us with your words on this special day. Special thanks to our club faculty coordinator, Ganesh Reddy, sir, for supporting us on every event and webinar. Last but not the least, I would like to extend my gratitude to our audience for coming and making this webinar a successful one. Thank you.
Thank you.
Thank you, Swati. Thank you.
Thank you one and all. It's
Thank
pleasure.
you.
You joined my you joined my webinar. You were being patient for 1 year, 1 hour. That's like it's give immense pleasure for me. So thank you one and all. Thank you, Varsha.
Yeah, thanks, Anna. Thanks for joining. On
Thank
behalf of our NGC team, thank you so much, Anna.
Sure. We'll meet once again even. Chalo.
Yeah, sure, Anna.
Yeah. Sure. Chalo.
Yeah, guys, officially webinar has been completed. You can leave.